Linear Inequalities and Graphs, Algebra 1 EOI Review. This lesson is over Standard 2, Relations and Functions, Objective 3, Linear Inequalities and Graphs. If you'll remember, Relations and Functions, Standard 2 is going to be the most highly tested standard on the Algebra 1 EOI. Of the 55 questions, 31 of them are going to be over Standard 2. And of those 31 questions, 6 of them are going to be over this standard, linear inequalities and graphs. When solving an inequality, we still want to isolate the variable, just like we want to isolate the variable when solving an equation. The one thing that you have to remember when solving an inequality is that when you multiply or divide both sides of an inequality by a negative number, you have to flip the sign. So if it was greater than, the sign is going to flip to become less than, and vice versa. So if it was a less than symbol, then we have to flip it and it becomes a greater than symbol. Graphing an inequality, if you'll remember, if you have just less than or greater than, you're going to plot an open circle on your number line at the point that that's written in the inequality. And then if you have a greater than or equal to or a less than or equal to, you're going to have a filled in or shaded circle at the point on your number line for the given inequality. It's going to be important that you read the inequality carefully to know which way you need to shade. So less than, if you had something like x is less than 3, then you would have to shade the numbers that are less than 3 on the number line. If you had x is greater than, then you would shade the numbers that are greater than on the number line. So just read it carefully and know, read it with your variable first, and then you can figure out the correct way to shade it from there. The first example says, what values of x represent the solutions to the inequality negative 2x plus 4 is less than 8? I first need to isolate my variable x to solve this inequality or find the solutions. The first step in doing that would be to subtract 4 from both sides. When I subtract 4 from both sides, I get negative 2x is less than 4. My inequality sign is never going to flip when I'm adding or subtracting numbers from both sides of an inequality. Now I have negative 2x is less than positive 4. I need to divide both sides by a negative 2. This is one of those instances, because I am dividing both sides by a negative number, in this case negative 2, my inequality sign is going to flip. So instead of having a less than symbol, when I flip the sign, it becomes a greater than symbol. So the answer is x is greater than negative 2, which is D in my answer choices. This next example says, which number line represents the solution set to the inequality 4 minus 4x is greater than or equal to negative 4? Before I can graph an inequality, I have to go ahead and isolate my variable by using inverse operations. So I'm going to start with the inequality 4 minus 4x is greater than or equal to negative 4. First, I need to get rid of addition or subtraction, which means I need to get rid of my positive 4 by subtracting 4 from both sides. When I subtract 4 from both sides, I'm left with negative 4x is greater than or equal to negative 8. Now I need to get rid of my negative 4 that's being multiplied by x by dividing both sides of the inequality by a negative 4. Again, just like in the last example, I'm dividing both sides by a negative number, which means my inequality symbol is going to flip, which means my final answer is going to be x is less than or equal to 2. I know I need a shaded in circle. It's always important to go ahead and check that first. If you'll notice, all 4 of these answer choices do have a filled in circle, so I can't eliminate any choices based on that. The inequality I'm trying to graph is x is less than negative 2, so I know C and D are not the correct answers because they have points at negative 2, and I need my point to be at positive 2. Now when I shade for x is less than or equal to 2, I need to shade to the left of the point, which is the numbers that are less than 2. So my answer here is going to be B. The next example is very similar. It says which number line represents the solution set to the inequality 6 minus 2x is greater than or equal to 14. Just like in the example above, I need to first get rid of my addition or subtraction, so I need to subtract 6 from both sides, which leaves me with negative 2x is greater than or equal to 8. Now I need to divide both sides by negative 2, and when I do so, my sign again is going to flip because I'm dividing both sides of my inequality by a negative, so I get x is less than or equal to negative 4. Again, I need a filled in circle, which does not eliminate any answer choices. However, I could eliminate I could eliminate B and D because they both have points at positive 4, and I need my point to be at negative 4. The inequality that is the number line that has the inequality x is less than or equal to negative 4 is A. This example says which inequality is represented by the number line. If you look at the number line, it has a filled-in circle at 6, and it's shading the numbers that are greater than 6. So my inequality that I'm looking for is x is greater than or equal to 6. Notice that all of my answer choices are not solved for x. So the first step before I choose my correct answer is going to be to go ahead and solve for x in all of these inequalities. If you look at A, I have x minus 6 is greater than or equal to 0. When I add 6 to both sides, I would get x is greater than or equal to 6. Again, on B, I need to add 6 to both sides, and I get x is less than or equal to 6. For C, I would need to subtract 6 from both sides, which gives me x is greater than or equal to negative 6. And the same thing for D, I get x is less than or equal to negative 6. Well, I know C and D are not the correct answers because the point of my inequality is at positive 6, not negative 6. And I'm shading to the right or in the greater than direction, so my answer here is going to be A. It probably wasn't necessary to go ahead and solve for x on all of those inequalities. However, it's good practice, and it's good to make sure that you know that A is the correct answer. If you would have made a simple mistake, you possibly could have caught it by going ahead and solving for your variable in all of the answer choices instead of just the first one. For compound inequalities, an and compound inequality is going to be shaded between the points on the number line. It's usually written with a variable between the two inequality symbols. So if you look at this example that's already on the screen below, A and B would both be examples of how and compound inequalities are written. Or compound inequalities are going to be shaded in the opposite directions from your points, and then it's usually going to be written with the word or in it. So if you look at C and D, those would both be examples of or compound inequalities. If you look at that example, it says which inequality is represented by this number line. Notice I have a solid or shaded in point at -1, and I have an open circle at 3. The shading for this inequality is between the 2 points, which means it's going to be an and compound inequality. Immediately, I can eliminate C and I can eliminate D because both of these inequalities would be shaded in the opposite directions. Now I need to pay attention to my points and what type of inequalities correspond with those points. -1 has a closed circle, which means the inequality needs to be an or equal to inequality. If you look at A, it says -1 is less than x, so A cannot be my answer. If you look at B, it says -1 is less than or equal to x, so B is my correct answer because it has the correct inequality symbols to correspond with the points plotted at the corresponding numbers. The next example says Jorge cut a 40-inch rope into 3 pieces. The first piece is 18 inches long. The second piece is at least 9 inches long, but no greater than 15 inches long. Which inequality represents the length x of the third piece? The first thing that I can do is I can go ahead and take the 40-inch rope that he starts with, and I can subtract how much I know he's going to cut for the first piece of rope. So I'm going to take 40 inches minus 18 inches because that's how long the first piece is for sure. And I'm going to have 22 inches left for the remaining pieces. Now it gives me a range of how long the second piece is going to be. It says the second piece is at least 9 inches long. So if the 22 inches if 9 inches is cut off of the 22 inches, I would need to take 22 and I would need to subtract the 9, which would leave me with 13 inches left for the third piece. But then it also says, but no greater than 15 inches long. So now I need to take 22 inches that's left after the first piece of rope is cut, and I need to subtract 15 from that number again. When I do that, if the second piece of rope was 15 inches long, then there would only be 7 inches left for the third piece. The inequality that says I'm going to have a range anywhere between 7 and 13 inches left for my piece of rope for the third length of the rope to be is going to be A. Graphing linear inequalities. First, we need to get the inequality in slope-intercept form, and we do that by isolating y. Then you're going to graph the line. The line is going to be solid for a less than or equal to or greater than or equal to inequality, and it's going to be dashed for a less than or greater than inequality. Then you're going to shade the coordinate plane accordingly. Some examples of graphing linear inequalities would be this first one says Rebecca has at most 8 hours to work on her math homework and her history report. The graph shows different combinations of math problems and history report pages she can complete. So this graph shows the amount of homework. The y-axis is showing the number of math problems. The x-axis is showing the number of history pages. If you'll notice, they've gone ahead and they've drawn a line and shaded below it because every point below in that shaded region is going to represent combinations that she can do in 8 hours of doing homework. It says, which of these combinations could Rebecca not complete in 8 hours? Which is basically asking us which of these combinations is not going to land in the shaded region of this graph. So what I'm going to do is I'm going to go ahead and I'm going to plot points corresponding with the situations they give me in A, B, C, and D. A says she can do 2 history pages, which means I would need to go to 2 on the x-axis, and 60 math problems. The combination of that work is represented by point A that I've highlighted on the graph. That is in the shaded region, so she could complete 2 history pages and 60 math problems. B says 4 history pages and 20 math problems. When I go to 4 on the x-axis and 20 on the y-axis, I land on point B on the graph. Again, this point is in the shaded region. It is a combination that she could complete doing 8 hours of homework. C gives us 8 history pages, and 50 math problems. When I plot 8 history pages and 50 math problems, I would be at point C, which is not in the shaded region, which means she could not do that combination of pages and problems in 8 hours of time doing homework. Just to be sure, I'm going to go ahead and find D. As long as D lands in the shaded region, then I know that C is going to be the combination that she cannot complete. D says 14 pages of history and 10 math problems. When you plot 14 pages of history and 10 math problems, you are on the line, but that is okay because in this case, my line is solid, which means any point that lands on that line is going to be a combination that could work. So my best answer here is going to be C. She could not complete 8 pages of history and 50 math problems in the 8 hours that she's allotted for homework. The next example says, which graph represents the inequality x plus 2y is greater than -4? The first thing that I want you to do is go ahead and notice that my inequality symbol is a greater than symbol right now. Now, notice it's not in slope-intercept form, but we know that greater than is not going to change to greater than or equal to or less than or equal to. So I can automatically eliminate choices B and D because they have solid lines. Remember, we use solid lines when we have greater than or equal to. We use dotted lines when we have just greater than or just less than. I need to go ahead and solve this equation for y to make sure I know the appropriate way we need to shade. So off to the side, we can do x plus 2y is greater than -4. Go ahead and subtract x from both sides, and you get 2y is greater than -x minus 4. When I divide both sides by 2, now when you divide both sides by 2, you have to divide everything on both sides by 2. My 2's are going to cancel out. My inequality sign does not flip because I'm dividing by a positive, and I end up with y is greater than -1/2 x minus 2. When y is greater than, that means I need to be shading above the line on the y-axis, so my correct answer is C. This example says which inequality is represented by this graph. First thing we need to look at when we're looking at graphs is graphs, is we need to look at our line. If you notice, this line is solid, which means it's going to be greater than or less than or equal to. If you look at our answer choices, though, that's not going to help us eliminate some, but it would have been nice if that would have eliminated 2 for us. We also need to look at our shading here. Our shading is shaded below the line on the y-axis. So we know that y needs to be less than or equal to, which means I can eliminate A and I can eliminate C because both of those say y is greater than or equal to. If y was greater than or equal to, I would have shaded above the line, and this has been shaded below the line. So I know B and D are going to be the only answer choices left. The only difference in choices B and D is the slope. So now I need to go look at the line and count the slope or count the rise over run of the line. Remember, choose 2 whole number ordered pairs and count rise over run. So I've chosen to count rise, which would be up 3, and run, which would be plus 2 from these 2 points, which means my slope would need to be a positive 3 over a positive 2. So my answer is D. Y is less than or equal to positive 3 over 2x plus 3. This last example says Juan is 3 years older than Pedro. The sum of their ages is less than 27. Let x represent Pedro's age. Which inequality can be used to find the possibilities of Pedro's age? The first thing that we need to look for is some keywords. It says the sum of their ages, first of all, which means we're going to be adding their ages together. It also uses this word less than. We know that less than is going to not have a line underneath it. So we can eliminate C and D. They are less than or equal to and greater than or equal to, which is definitely not going to be my inequality. Now we're going to go ahead and look at this inequality and go ahead and write it. So if Pedro is X years old, Juan would be 3 years older. So Juan is going to be whatever X is plus 3. It says their sum of their ages is less than 27. So Pedro's age, X, plus Juan's age, X plus 3, has to be less than 27. Well, X plus X is 2X. So 2x plus 3 is less than 27, which is my answer B.